Hello, you're welcome back. All right. So the topic is indices, and here we are going to be looking at revision questions. Okay. So in this video, we are going to be solving a lot of examination questions. So I'm going to start with the very first question here. All right. So solution. Now, we are to evaluate 16 raised to the power of 0 0.16 times 16 raised to the power of 0 0.04 times 2 raised to the power of 0 0.2. Okay, now looking at the question, it looks somehow difficult and of course logical, but simply can solve it by applying the law of indices. Okay, so what I have to do is that I'm going to express 16, right, this base in an index form, right? I'm going to express it in the lowest index form. Okay, let me put it this way: I'm going to express it in an index form with the lowest base, right? So the lowest base I will get out of 16 is 2. So I'm going to have 2. Of course, 16 is 2 raised to the power 4. That's going to be 4. Of course, already we have 0 0.16, all right? 0.16 as the power. So I'll put that in a bracket. I'll do the same to this. That's going to be 2 into raised to the power 2 raised to the power 4, right? Of course, raised to the power of 0.04. Then, of course, times 2 raised to the power of 0.2. All right. So now, if you multiply 0.16 by 4, all right, okay, that you should have 6.4 if I'm not mistaken. But let me do that. Okay, 0.16 multiplied by 4. Okay, that's 0.64. 0.64. Then of course, if I multiply this by 4, okay, so I should have 0.16. Okay, so let me confirm that. 4 times 0.04, yeah, 0.16. Then of course, if I should multiply, all right, this already is 2 raised to the power of 0.2. So at this point now, you know what we are going to do. Since I'm now having the same base, all right, for the 3 indices, okay, for the 3 index, all right, so I'm going to apply the addition law. Just write one base, then add the powers. That's 2 raised to the power of 0.64, then plus 0.16, then plus 0.2. All right, here we go. So let's add up. So I'm going to add the powers, which of course is 0.16 plus 0.2 plus 0.64. That is 1. So everything is 2 raised to the power 1. And of course, 2 raised to the power 1 is 2. As simple as that. Okay. Next question. Here we go. Okay, so now this one is a question, all right, from solved. So it's a solved question. So we have to simplify 1 all over 3 minus root 2 in the form of p plus q, then root 2. So we are to simplify this particular sort, then we'll now express it in this form. All right, solution. You know very well that once you see this sort, right, this type of sort, simplifying this sort is simply rationalizing that sort. Okay, so you are to rationalize that sort. And since the denominator is having a minus sign, okay, so the only way to rationalize this sort is to multiply the numerator and the denominator by the conjugate of the denominator. Look at what we have in the denominator. We have 3 minus root 2. Not just root 2 separately, not just 3 separately, not 3 root 2, but there's a minus. 3 minus root 2. Okay, so now for us to rationalize, let's rationalize 1 all over 3 minus root 2 is going to be equal to multiply the numerator 1, all right, by the conjugate. What is the conjugate of the denominator? All right. The conjugate of the denominator is still the same denominator, but the sign will change to opposite sign. So if it is minus, I will change it to plus. If it is plus, I'll change it to minus. So in this case, it is minus, all right? So I'm going to change it to plus. So I'm going to have 3 plus root 2. All right. So then, of course, divided by the same thing. Whatever you do to the denominator, to the numerator, you also do that to the denominator. So the same sort in the denominator are still multiplied by the conjugate, which of course 3 plus root 2. All right. So at this point, you know, 1 multiplied by 3 plus root 2, I will still have 3 plus root 2. All right. Then of course, looking at the denominator, you can see that the two brackets, they are the same. But what differs is that one bracket is having plus while the other is having minus. That is what we call a mathematics difference of two squares. So you don't need to bother yourself trying to expand this, okay? Expanding this is just very easy. All you just need to do is just take the very first value, square it, then bring minus, then you square the second value. The square root of 2, the square root of 2 square. Now let's do that. All right. So this is going to be 3 plus root 2, of course, divided by the square root of 3 is, of course, 9. And the square root of 2 square. 2 square is 4. The square root of 4 is 2. Okay, so I'm having 9 minus 2. And of course, 9 minus 2. All right. 9 minus 2 should give me 7, right? Yes. Okay, so 9 minus 2 is 7. But remember, we are being asked to express it in this form, okay? Expressing the sort in this form simply means that the very first number, the other which is b, should be a normal whole rational number, while the other one should be a sort. So what I'm going to do, I'm going to split this. So I'm going to have 3 all over 7, okay? Because it's a fraction. When you see 3 plus root 2 all divided by 7, all over 7, that means 7 is dividing 3, and root 2 is also dividing, is being divided by 7. So I want to split it. So I'm splitting 3 all over 7, then plus root 2 all over 7, okay? So that is the only way it is expressed in this form. All right. I hope that is well understood. Moving on to another question. All right, similar question, solved. Solved. Okay. Solution. Okay, so in this case, we still have to rationalize. Okay, then we express, as we rationalize this sort, we express it in this form. By expressing it in this form, you will be able to pick out A and B, all right? Okay, so let's rationalize. This is 3 root 3, okay? All over 2 plus root 3. So you know what we do? I'm going to multiply the numerator, which is 3 minus root 3, by the conjugate of the denominator. The conjugate of the denominator is 2 minus root 3. All right. So then, of course, divided by whatever I do to the numerator, I also do that to the denominator. So 2 plus root 3 are still multiplied by the conjugate, which of course is 2 minus root 3. All right, so you know exactly what is going to happen here now. All I'm just going to do is to, I'm going to expand the numerator. 3 times 2. 3 times 2, of course, will give me 6. 3 times root 3, that's going to give me minus 3 root 3. Okay. It's like, I'm not going to, that space there will not be enough for me. So let me just bring it down here. Okay, let's multiply. 3 times 2 is 6. 3 times minus root 3. That's going to be minus 3 root 3. Okay, so now I start multiplying by root 3. Minus root 3 multiplied by 2. That's minus 2 root 3. Then minus root 3 multiplied by minus root 3. That is plus. Plus root 9. The square root of 9. Okay. Of course, you know how we expand the denominator, difference of 2 squares. So that's going to be the 2, I will square it, minus the square root of 3, I will square it. All right, so this is going to be equal to, you know what I'm going to do? Calculate. First of all, if the square root of 9, right, will give me 3. It's a rational number. So the like terms now is the 3 that I have here plus 6. 3 plus 6, and of course 3 plus 6 is 9. Okay? Then adding up the other, the sort. Here I'm having minus 3 root 3, then minus 2 root 3. Okay? Of course, the root 3 is like a common factor there. So minus 3 root 3 minus 2 root 3 will give us minus 5 root 3. Minus 5 root 3, okay? Minus 5 root 3. It's just like having minus 3x minus 2x, okay? So what I'm going to have is minus 5 root 3, okay? Of course, divided by 2 square is 4. All right, and then, or better still, let me not go through that long process, okay? So 2 square here is 4. Then, of course, 3 square is 9. The square root of 9 is, we already know, okay? The square root of 9, the square root of 9 is 3. So I'm going to have 4 minus 3, which, of course, is 1, okay? So, of course, 9 minus 5 root 3 divided by 1 will still give me the same thing. So my answer is 9 minus 5 root 3, all right? So remember, we are to actually compare it with what we are being asked to find. We are asked to find A and B, all right? If I compare this to A plus B root 3, all right, you can actually agree with me that A is going to be equal to 9, all right, comma, and of B definitely will be equal to minus 5. So that is the answer to that. As simple as that. All right, here we go now, a question on logarithm. Logarithm. Okay, so let's do justice to it. So this is a solution. All right, so let's begin. Here I have this log plus this log is equal to this log plus this. So that's one thing you should notice, all right? At the left-hand side of the logarithm, all right, I have plus. There are two logs, okay, that is connected by addition. So in that case, you know the law I'm going to apply. I'm going to apply multiplication law, okay? So since it is plus that is here, I'll apply multiplication law. This is same as log y plus 8. Of course, multiply by y minus 8, okay? Don't forget you just need to write only, okay, only one log, all right? Then you multiply the logarithm. Multiply this and multiply this, all right? Okay, the same thing now. Before I can apply this law here unless I actually remove the 2, okay, which of course is the coefficient of log 3. And that coefficient of log 3, that is power law, right? If I take it to where it's supposed to be 3 raised to power 2. So this was supposed to be 3 raised to power 2 because it was these 2, all right, that that actually came to the back as a coefficient, right? These 2 as a power law. That is power law in logarithm, and the same thing happens to this. So this is going to be equal to log of 5 raised to the power of 2. All right, so let's proceed. Okay, so here we go. I'm very sure that you know exactly what, looking at this, the left hand side, log y plus 8 and log y minus 8. The two brackets are the same. What differs between them is the fact that one is plus and the other one is minus. I know what that is, difference of 2 square, don't forget, right? So to expand that bracket there, all I just need to do is square y, then minus, I also square 8. All right, so equal to, now I can apply the, okay, the multiplication law. First of all, 3 raised to the power 2 is 9, and 5 raised to the power 2 is 25. Okay, so that's going to be equal to 9 times 25. Okay, and of course, I was not given the base. I don't even need the base. Since there's log both sides of the equation, then definitely the log will cancel out. Okay, log, the log will cancel out. All right, so if the log cancels out, I'm going to have y squared minus 8 squared is equal to 9 times 25. Okay, all right, so let's do that. 9 times 25, 2 to 5. All right, so here I'm having 2 to 5. Okay, so this is going to be equal to y squared. Is it going to be equal to 2 to 5? Of course, x squared is 64. Take it to the other side of the equation. That's plus 64, right? Okay, so let's add up. 2 to 5 plus is 64. Okay, 289, right? So 289. So that simply means that y now is supposed to be the square root of 289. Plus or minus. Okay, sometimes okay, you have to add that plus or minus. Okay, because that's quadratic. Okay, let's do that. The square root of that, 17, simple. All right, so y is equal to plus or minus 17. Okay, so you can decide to choose the plus. So y is equal to 17. All right, always choose the positive values. Choose the positive value of any equation, all right, that you have, especially in quadratic. If you have to choose just one, choose the positive value, all right? So that means y is going to be equal to plus 17. Okay, so here I have another equation in logarithm. Solution. Okay, so now in this case, this is kind of tricky, but we're going to do justice to it. So what I'm going to do is I will collect items, okay? So I'm going to move this log x in base 2 to the other side of the equation, all right? So what I'm going to have, I have log, all right, 6 minus x in base 2, all right? Then I move minus log x in base 2. Okay, to that side, of course, if I move it, it will become plus, okay? This part of me, it will become plus. Then it's equal to 3. You know the law I'm going to apply here? Multiplication law, right? So I will just write one log and multiply, right? 6 minus x, then times x. Don't forget the base, but the base is 2. Is equal to 3. So in this case, I know very well that there is no log both sides for me to be able to eliminate the log. So the only way to eliminate the log is to take the exponent. All right. So because if anytime if you want to eliminate log, use exponent. Okay. Take exponent, and the base you are going to use, I'm going to use base 2 since the log is having base 2. Okay. So I will take the exponent in base 2. All right. Of both sides. Okay, so that simply means that I'm gonna take the exponent, that's 2 raised to the power of the log of 6 minus x, okay, multiply by x. Of course, this is in base 2. I'll do the same. I'll take the exponent. That's going to be 2 raised to the power 3. Okay, in mathematics, exponent, this base, all right, the base of an exponent will always cancel the base of the log. So this will cancel this, all right? So I'm now left with, of course, let me open this bracket at once. X multiplied by 6, that's going to give me 6x. X multiplied by x, that's going to give me x squared. All right? Is equal to 2 raised to the power 3 is 8. All right, so now this is actually bringing me to quadratic equation. So to solve this, this is going to be a quadratic equation solution. So what I'm going to do is that I'm going to transfer all the expression of this equation to one side, okay? So what I'll do, I'll transfer everything to one side where I'll transfer it to the side that will make s, this minus s squared, to be positive. So if I transfer it to, let's say, to the right-hand side, okay? I can still write it anywhere, though. So let's say, or better still, all right? That's, let's say I'm taking it to the side, I'm going to have s squared. If I take this to the other side, I have minus 6x. So already 8 is already there, that's plus 8, okay? Then everything is at one side now, all right? Then this is going to be equal to 0. Okay, so now how do we solve this quadratic equation? We can solve it by factorization, okay? So I think this is a good opportunity to teach you how to solve quadratic equation by factorization. What I would do is I multiply the first term and the last term and write it somewhere in a rough, okay? S squared multiplied by 8, that's going to be give me 8s squared, all right? Then I will actually split this, okay? So I'm going to give you the opportunity to solve this quadratic equation, all right? Tell me what the answer is. Then in the next video, I'm going to show you how to solve it, all right? See you in the next video. Thank you. Hello, you're welcome back. All right. So